Hello and welcome to Unit 3, that should say Notes 3. And so today we're talking about dividing monomials. So again, this is Notes 3, okay? Um, so we're going to be working with the rules of exponents that you guys were working on in your last notes. So let's take a look at those again real briefly. So first of all, we talked about how when you multiply like bases, you add exponents. Now this isn't on your note sheet because you have it on your other note sheets. So here's what we were looking for today. Okay, so when you're dividing things of like bases, okay, remember like bases means the same letter, the same number. That's what a like base is. You're going to subtract the exponents. So for example, for this first example, you have a to the 6th divided by a to the 3rd. So we want to go ahead and we want to subtract those exponents. Same base being divided, so we're going to subtract the exponents. So 6 minus 3 gives us a to the 3rd. The only other rule that we need to talk about today is the negative exponent. So this is where we want to flip the location. Again, those are your rules from yesterday. We're going to kind of be using them all today. So negative exponent is when you flip the location. So for example, if a letter has a negative exponent and it's sitting on top of the fraction, to get rid of that negative exponent, we're going to switch it to the bottom. Likewise, if something's on the bottom of the fraction, it has a negative exponent, we want to flip it to the bottom. So this b to the negative 4th needs to come up top, and this a to the negative 1 needs to go to the bottom. So we're going to go ahead and flip-flop those. So the b to the 4th is going to come up top, and the a to the 1st is going to come to the bottom. Now we can't simplify this any further because b and a are different letters. We cannot divide subtract the exponents because they are being divided by different bases. So that is as simplified as it gets. Okay, so here is the biggest thing that I see students making mistakes with. So this is just a little note underneath your chart there. Remember when you're dealing with negative exponents that you need to flip the location of just the variable with the negative exponent. I see a lot of students trying to flip the entire thing because they see a negative. Be careful that you're only flipping the thing that has the negative exponent, nothing else. Okay. So let's take a look at some of these examples. Okay, let's take a look at number 1. So I'm going to divide things of like bases. 4s can only go with 4s. A's can only go with A's. B's can only go with B's. Well, the only thing that we have the same of are this A. So we're going to subtract those exponents. So remember, if there's no exponent, that's the same as taking each of those to the first power. So we have 4a to the first, b to the first, over a to the first. So we have 4a, and now we're going to subtract those exponents. So we have 1 minus 1. And then we also have b to the 1. Okay, so we want to keep simplifying. I don't want to leave that 1 minus 1 in my exponent. So I'm going to keep simplifying. I have 4a to the 1 minus 1 is a to the 0. And then b. Well, we just learned yesterday that anything to the 0 power is just going to be 1. So this is the same as 4b. I could have it multiplied by 1, but multiplying the 1 by 1 is the same thing as 4b. It's going to keep it the same. So now we're going to take a look at number 2. So number 2, we want to deal with that negative exponents. Nothing is simplified if it has a negative exponent. So there's no fraction on this. So this is the same thing as 4a to the negative 2 divided by 1. So I want to take just the thing with the negative exponent, and that's going to flip. Notice that I'm not flipping that 4 to the bottom of the fraction, just that a to the negative 2. So we're going to divide it, and then we're going to have a to the 2. So once I've flipped it to the bottom, then that fraction is going to that exponent that is negative is going to become positive. Okay, so 4 over a squared. Let's take a look at number 3. So number 3, again, we want to get rid of any negative exponents that we have. So I see that this b to the negative 2 is negative on the bottom of the fraction. So I need to flip it to the top in order to make it positive. Okay, so I'm going to flip that fraction to the top. So I have 6a, and then b to the negative 2 needs to come up to the top. When I flip it to the top, I give it a positive exponent. So my final answer on that one is 6ab squared. Now I want you guys to pause the video and try number 4. I really want you guys to make sure you're actually trying these. It's very important. Okay, so then you can see what you do and don't understand when we come back and talk about this tomorrow. Okay, so let's take a look at these properties of simplified monomials checklist. So this is for when we're dividing monomials. We want to make sure all of these things are happening. So if I'm talking too fast for you to write it, please pause it, okay? I don't intend for you to write this in the span that I'm talking. In fact, I suggest pausing it, writing it, and then you can listen to me speak. So each base appears exactly once. We don't want to have more than one a. We want to have one a raised to whatever exponent it may be. Okay, we don't want to have powers of powers. These are all from our multiplying monomials. It's the same idea. We don't want to have a squared and then that whole thing cubed. We want to reduce that because we know how using rules of exponents. We also want to make sure that all of our fractions are in simplest form. Okay, so we're going to reduce those fractions. Instead of having 4/6, we're going to make that 2/3. You want to reduce those fractions. And last but not least, we do not want negative exponents. If you have any negative exponent left in what you're doing, you did it wrong or you're not finished. Okay, so make sure you're keeping track of that. All right, so let's talk through a couple of these. So I'm going to try number 5. Okay, so all I'm going to do with these is I'm going to simplify it base by base. I'm going to start with a's. So I have a to the 5th divided by a. So this is the same as a to the 1st. So on top, that's hard to see. On top, I have a to the 5 minus 1. And then I'm going to deal with my b's. Okay, I have b to the 8th divided by b cubed. So I'm going to subtract those exponents, 8 minus 3. So let's take a look at what we have then. 5 minus 1 is going to give me 4. 8 minus 3 is going to give me 5. So that's fully simplified. All I did was subtract the exponents. Go ahead and I want you guys to pause the video. Try number 6, okay? It's really similar to what I just did in number 5. So subtract things of like bases. Remember, if there's no exponent, the exponent is 1. All right, let's take a look at number 7. So number 7, what we're going to do is we're going to distribute in that exponent to start off with. So we have 1 and 1. Okay, so what I want to do is I want to take each power and multiply it by 4. So I have 2 to the 4. So I'm taking this power of 4 and I'm multiplying it by each exponent. Okay, so I have 2 to the 4. And then I'm going to multiply 2 times 4, which is 8. And on the bottom, 3 to the 1 times 4. Notice I'm multiplying the exponents, not the numbers. Okay, that's really, really important. So 2 to the 4th power is going to give me 16. And then I still have p to the 8th. And then I have 81. Okay, so that's fully simplified form. There's nothing that goes into 16 and 81. We cannot reduce that fraction. All right, let's go ahead and do number 8 together, just for some more practice. So remember, if there's no exponent, the exponent is 1. Notice I'm putting 1s on the numbers too. When you're taking a power of a power, you need to make sure that you're distributing that 2 even to the numbers as well. So this 2 needs to go here, 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 and there. Okay, so now I'm going to multiply through those exponents. 1 times 2 is 2. 5 times 2 is 10. 1 times 2 is 2. And lastly on the bottom, 1 times 2 is 2. So now I want to go through and simplify this out a little bit. I know that 5 squared is 25, and then I have x to the 10th and y squared, divided by 6 squared, which is 36. Okay, so that's fully simplified. I can't reduce the fraction. I can't do anything to combine any more bases. So that is my fully simplified answer. Now let's take a look at number 9. Number 9 looks kind of tricky, but I think we can handle it. Oops, number 9 is on here. So as a video treat, you guys can go ahead and skip 9 and 10 because they're actually really similar to what we've been doing. So you guys can go ahead and skip those. Let's take a look at number 11. Now 11 and 12 just get scarier and scarier. So what we're going to do first for number 11 is I always want to take all of my negative exponents and switch where they're located. So I'm taking anything that's negative and switching where it's located. So my c squared is staying positive on the top. This d to the negative 5 is negative on the bottom. So I'm going to flip it to the top, and by flipping it to the top, it becomes positive. And then I have b to the negative 3 on top. I'm flipping it to the bottom, and I get b to the 3rd. Okay? I can't combine any more like bases. I can't simplify anymore. So I'm going to stop there. There's nothing more I can do to simplify that. So let's take a look at this one. This looks like a whole crazy mumbo jumbo of stuff, but you know what? We can do it. So here on the bottom, I have c to the negative 5. So I'm going to take that and flip it to the top. Up here, I have a to the negative 4, so I want to take that and flip it to the bottom. I like to start by getting rid of those negative exponents to start off with. So on top, I'm just going to have negative 3, b to the 7th, and that c to the negative 5 is going to flip to the top, and that's going to make it have a positive exponent. Then on the bottom, 21, a squared, b to the 7th, and then that a also flipped to the bottom, so I also have an a to the 4th. So now I just want to work on simplifying and combining like bases. So let's go ahead and do that. First of all, I have this fraction, negative 3 over 21. I can reduce that fraction to make it a little bit even more simpler. So I'm going to have a 1 on top, and that 3 divided by 21 is going to give me a 7. That should be a negative 1. Okay, so I just reduced that fraction to negative 1/7. Well, let's take a look at my a's. Well, my a's on the bottom, I have a squared and I have a to the 4th. Those are basically being multiplied on the bottom of the fraction. So because they're being multiplied, I'm going to use that rule of exponents, and I'm going to add their exponents. Multiplying like bases, you add the exponents. Next thing I see these b's. I see b to the 7th over b to the 7th. Let's take a little field trip. So if I'm dividing b to the 7th over b to the 7th, that's the same thing as b to the 7 minus 7, which is the same thing as b to the 0. So that's 1. Have you ever wondered why any number over itself is always 1? 6 over 6 equals 1. 7 over 7 is equal to 1. Here's why. Okay, rules of exponents. Anything to the 0 power is 1. Okay, that's how this works. So these b's just cancel out into 1, so we don't even have to write them. They're included in the one we've already written. Last but not least, we have this c to the 5th that we want to make sure we write down. If you wanted to simplify it even farther, you could get rid of that 1 and just write this as negative c to the 5th. You don't have to, but it's something you can do to simplify it a little farther. Okay, let's take a look at these. Again, these look crazy scary, but all I suggest is taking it letter by letter, bit by bit. So the first thing we're going to do is I'm going to get those negatives, and I'm going to bring them to the correct side. So this q to the negative 2 is going to come down. This r to the negative 3 is going to go up, and this s to the negative 5 is going to go up. So I'm going to take care of all of my negative exponents. So then I have negative 3, I have r, and then I also brought up an r to the 3rd, and then I have s to the 4th up there, and I also brought up an s to the 5th. Remember, when you bring them to their locations, when you flip them, you can make them positive. On the bottom, we have negative 12. I have a q down there. I also brought down a q squared. So now we're just going to simplify these and multiply them out. So negative 3 over negative 12, that's going to reduce to 1/4. Okay, on top I have r to the 1 times r cubed. So when you're multiplying those, you add the exponents. So on top I have r to the 4th. S times s to the 4th times s to the 5th. We're going to add those exponents. So on top I have s to the 5th. Q to the 1 times q squared. Add those exponents, and you get q cubed. Again, you can simplify it by getting rid of that 1 if you'd like. Okay, I'm going to have you go ahead and pause this video. Okay, I want you to kind of try some of these on your own. Remember, this looks really scary, but take it piece by piece. Remember to reduce that fraction. Last but not least, let's talk about this word problem. Okay, this is going to blow your mind. I'm going to get it set up for you, and then we'll talk about it more in class tomorrow, okay? So see if you can finish it, and then we'll talk about it in class tomorrow. So here you have this diagram. The area of a circle is pi r squared. So our r in this circle is t. So the area of a circle is pi t squared. Okay, pi t squared. Now, to get the area of the square, you do length times width. Well, our length is t and t. So our length all the way across is 2t. So our length then would be 2t times 2t. Okay, so I want you to go ahead and simplify that out on your own and see if you can divide the monomials. Please remember to take the quiz once you've finished.